Okay, and if we go through this question, the key word for me is this word that says group frequency diagram. And there's two questions you can get asked. You can ask a frequency polygon or a group frequency diagram. And once I did see it where they called it a grouped frequency polygon. The word diagram tells you what to do. That tells you it must be a bar chart. So I'd recommend writing next to that word diagram, bar chart. A polygon would suggest it's a line graph. Okay? The difference between a normal bar chart that you've done like back in the day in year 7 is that this time the bars will touch because it's continuous data. So if I start scrolling down showing what we had, they already did the scale for you on the axes, which is always a bit of a treat, I know. Scale here, you work out, if you look at this number 10, you work out how many little squares goes up the side here. So if I sort of bring attention to that, there's 10 little squares that go into that, so that's why it's 10 divided by 10 equals 1. So then looking at that, it should be a bar that if you look at the numbers here, if I zoom out a little bit there, you see there 50 to 55, it runs that bar there, and they all touch like that, okay? So that's what it should look like. Frequency polygon, anyone know what that would look like? I said it's a line graph. Anything special about where it's plotted? It needs to be plotted at the midpoints. Okay. Question. What I would definitely recommend doing is actually on the bars writing how much each bar is worth. So you can see there 20, reading it off from the frequency there, 30, 15, 5 and 5 and so on. I tend to actually write the numbers just a little bit higher, write it on the bar, like just a little bit higher here. It doesn't really matter the way you write it as long as you've got it in there. Just make things a little bit easier for the next bit. So how many logs did Billy collect and measure? You add together all of these frequencies to find a total of 75. And then just going on to the second bit. Was it Tom or Billy who collected the longer logs on average? It's Tom, because the bars on the right, there's more bars on the right for Tom. So if you look where this graph peaks here, if I look on the... Okay, so the key word in the question, scale factor 2, that means you get 2 times bigger. So if it's scale factor 2, 2 times bigger, scale factor 3, 3 times bigger, scale factor a million, million times bigger. Scale factor half, though, would actually make it smaller. So an enlargement can get smaller if it's less than 1. Okay? Also, it says using A as a centre of enlargement. So that means using this point A, that you count how many squares you get from A to this point here. So if you count down 1, 2, 3 down, and 1 to the right, reset, go all the way back to A, double that. So instead of going down 3, go down 6. Instead of going across to the right 1, go across 2. Okay, so if I zoom across here, you can go 1, 2, 3, 4, 5, 6 down, and then 2 across. So that's how we've got to that point there. Okay? The next bit is up to you. You can either do it for all corners, or a posh word for corners that you might read in an exam, vertex or vertices. You can do it for all corners if you want. Not my personal preference. I find a much quicker way is to go and measure how long this line here is. So if I look at that, what's that, 4 squares? I know it's had a scale factor of 2. Scale factor of 2 means it needs to be twice as big. So instead of being 4 squares, this line is now 8 squares. And then I just follow the rest of the shape. It then goes across 3 squares. So now it goes across 6 squares. Be very careful with diagonals, though. Unless it's a true diagonal where it goes from one corner to the other, it can be something you can mess up quite easily. If you haven't got like a true diagonal, I'll do all the straight lines first and then join up or any diagonal lines, okay? So then that one there being just 1 square, twice as big, and then up 1 square, so up 2 squares, and then join it back to the start. Okay? Yeah, this next part here, y equals minus x. Diagonal lines, people hate drawing. First of all, what is y equals minus x? Well, y equals x is the value when whatever the value of x is, it's also the value of y. So that line, y equals x, goes through the origin and sort of does a diagonal line here. So when x is 1, y is 1. When x is 2, y is 2, and so on. Okay? Minus x is the opposite way around. So whatever x is, y is minus that. So when x is minus 2, y is minus minus 2. Minus minus is a plus 2. So that's why it does this diagonal line here. The diagonal then people commonly mess up. Like the way I do it, I don't know if it's the same as you, miss, is I count here, I say, right, I go 1, 2, 3, 4, 5, 6 to the line here. So now it goes the opposite way here. So it hits the line and goes straight up like that. So 1, 2, 3, 4, 5, 6 to the line like that. And then I do it for every single corner, and then I join the lines up. If you're unsure, that is what you get tracing paper for in the exam. Okay, I can see a few bits of tracing paper out. What you need to do if you're going to trace it is you trace the shape, and most importantly, you trace the line as well. If you don't trace the line, you'll get it wrong. Then what you do is you physically flip over your tracing paper and match the line of symmetries up with each other. And if I did that on mine, hopefully, it should do, it would meet up exactly where I've said it. Okay? And what you can do then, once you've flipped your tracing paper, if you use pencil on that, if you actually trace over your shape again, it will imprint what you've just done on the tracing paper onto your paper, so it will definitely be in the right place. Okay?
It's too much.
Bits of information then on this bit. There's 3 of them. 90 degrees, anti-clockwise. That word anti-clockwise being absolutely key there. And the point, -2, -4. So, clockwise, no, it sounds obvious, the way the hands move around a clock. Try and picture a clock in your mind. So, anti-clockwise, the opposite to that. This thing here, still at higher tier, we still see the same mistakes made as foundation. They forget where to plot it. Saying that we still use, I still think of it myself when I have a plot, along the corridor, up the stairs or down the stairs. So across to -2, down to -4. So your point should have been there. Now, something I always do is actually where that point is then, I draw like a crosshair. The reason why I do that is this is split into 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Definitely something that's worth doing. It always makes it very easy to do this question if you draw that crosshair. When you trace the shape, I saw loads of using tracing paper, which I was really pleased to see because I can't actually do this without tracing paper myself. I like to use tracing paper. You trace your shape and the crosshair. Okay, your pen then goes on the point there, so hopefully you can see my little laser in there, actually on that, and you turn the paper not this way, because that would be going the ways that hands go around a clock, the opposite way to that, and 90 degrees would just be one sort of like crossover on the crosshair, and it should be that it does meet up exactly on the squares here. Now and again you tend to see that people have done the right idea, but like their shape doesn't quite match up on the squares. Here it's on the lines, so here it's got to be on the lines here. Okay, so it should look something like that.
I don't know the wrong way I did. I twisted it the wrong way.
Okay, you would still get 1 mark for that. It's just about reading that question. So hopefully, Lewis, the best thing for you to do is to go up and just really emphasise the underlining of anti-clockwise. It's easy to make that mistake. That's why we're going over them in this manner, okay? Expanding means whatever is on the outside here must multiply both of the things that are on the inside of the bracket. So the thing that I would definitely recommend doing is I'd definitely recommend drawing the arrow there because it will remind you to multiply both things. Thank you. So y times by y to the 5, you add those indices together. So that's why that's become y to the 6, because y on its own really is y to the power of 1. Okay, so you may want to make that little note there. You don't have to, though. And then y times by 3 is 3y. And then the factorised bit, thank you. The factorising bit, Nathan, you said it really well. You said, does that mean put it back into brackets? That's exactly what it means. That's what factorise means. It means the opposite of expanding. They tend to come one after the other if they're together. Factorising then, so you pick out what is a common number or letter or both in each of these. So 4 and 2 goes into both of those. X cubed and x are the same letter. So outside has come 2x, and then inside you divide 2x by each of these things here. So if I have 4x cubed, divide that by 2x, well, 2 goes into 4 twice, and then this is x to the 1 really, and then when we times them, we added together the indices before. Here we do 3, take away 1 to get the x squared, so that's how the 2x squared has become there. And then the same thing here, you do 2x divided by 2x. Anything divided by itself is 1. Okay. The reason why it's minus 1 is because it was a minus there. So I'll show her way. I'll try the best I can to explain it, but I do have her here, so she may be able to sort of help me out here. She said that he's kept 2/3, so he must have given 1/3 away. Actually, your way is better than mine. So 1/3 split into 24ths because you had each person getting 1/24. So then 24 divided by 3 giving 8 tells you had 8 close friends. But I put my way here. This is the last question on the foundation paper.
Should we write that down?
Yeah, sure.
I don't
Okay, well, I'll show you my way and see if it makes any difference.
It's actually THS 24.
Yes, 24ths.
Oh, thought.
Okay, so the way I did it then, I'm hoping I can find. Yeah, there we go. I split it into, because he had 2/3, and because each of his friends he gave 24ths to, I changed 2/3 into 24ths. So this is an equivalent fraction, so I times this by 8 and got the 24, but whatever I do to the bottom, I've got to do to the top, so I got 16. So 16 24ths, and because everything that you have is out of 1, one take away the 16 24ths gave me 8 24ths, because this number here as a fraction would be 24 over 24. So 24 take away 16 gives the 8, and then denominators on a fraction. 8 24. So it tells me that he had 8 24ths left, and he gave each of those friends 1 24th. So 1 going into 8 times. So that's how I came up with mine. What do you prefer, Miss Lloyd Hughes? Do nothing can be better than your way, Miss. Okay, so first thing that you can see here that Miss has done, she's highlighted all the important words. Also, whenever you read this thing here, quality of written communication, that is worth 2 of your 7 marks. So don't forget the maths is still mega important here. 5 marks on the maths, 2 marks for making it written and certainly accessible to someone who's marking your work.
You know those 2 marks is just for putting like a line, like a sentence in there.
What, these 2 marks here?
Yeah.
So 1 mark will be for having like clear maths that someone can follow, and 2 marks will be for having a well-written answer that someone can. Does that make sense, Miss? That's the right things there. So the important maths bits then, all the ones highlighted here, smaller share of that amount of money in the ratio there, 6% of his annual salary. Okay, so the way that Miss has tackled this question is whenever doing ratio, you add together the parts of the ratio, 2 and 3, so you get 5 parts, and then if you do the total sum of money, so the 2,500, if you divide that by 5, you find that 1 part of the ratio is worth £500, so he gets the smaller share, so the 2, so if you times the 1 part by 2, you get 2 parts, which is £1,000. Okay. For the next bit, 6% of his annual salaries. A lot of you probably found 10% first. Miss has gone straight into 1 to find 10% divided by 10, to find 1%, divide that by 10 again. Or, if you wanted to skip that, divide it by 100 to find 1% straight away. Okay, so 17,000 divided by 100 gives you 170. He gets 6% though, so you now need to multiply that by 6. So times that by 6, have you partitioned that, Miss, into 170? So 6 times by 100, giving 600. 6 times 70, giving you 420. Putting the pieces together to get 1,020. And then finally, summarising which one he should go for. He should go for the 6% because he gets £20 more. Okay? The first thing I'll say, a common misconception that you tend to see is people see the 105 there, and they've been told that all obtuse angles are the same. That's true anywhere along this line here, but this line here has got absolutely nothing to do with the angles you see on this side here. Okay? If you wanted to, you could go and write in 105 there, 105 there, and in 105 here, but, like I said, this line has got absolutely no relevance to this line here. Okay? To work out this angle here, the one angle Y, you're going to use angles on a straight line, add together to 180, so 180 take away 105 gives you 75, so we now know in here is 75 degrees. Then, looking in here, we have the shape of a triangle, so adding together your angles and then taking away from 180 again, we work out angle W by here. And then along this line here, all acute angles are the same. So if that's 55 there, then that must be 55, this must be 55, and then finally this one here must also be 55. Miss has already highlighted loads and loads and loads of stuff that you had to try and pick out quite a lot. They're trying to get you to put algebra into like a shape, space and measure question. So it is always going to be quite difficult. obviously you've got to know what this this shape is. So like I was saying out loud, it's like a pushed over rectangle, so something like that. Definitely be drawing that, definitely. Okay. Trying to put that information into like a diagram, we're told that the shorter side was Z and that the longer side was 2Z. No, we weren't told that. We're told that it's twice as long.
Do you know what side is what or not?
We don't know what either is. Okay. We're told to let the shorter side be Z and that this side was twice as long, so 2 times Z is what we call 2Z. And then it told us that the perimeter was 24 metres. So then adding together all the sides of perimeters, the journey around the shape, so that plus that plus that plus that,
24, yeah.
comes to 24. Collect all your like terms. 2Z plus 2Z is 4Z. Add a Z, 5Z. Add another Z, 6Z. 6Z equals 24. Divide each side by 6. Gives Z equals 4. You might have another maths teacher that doesn't do it quite the same way as this. They will have said take the 6 over and it becomes a divide by 6. Still fine if you want to do that. So Z equals 4 centimetres, and that's what we asked. It said solve your equation to find the length of one of the shorter sides. It didn't say what's the longest side, so you're done as soon as you work out that's 4 centimetres. You can if you want. Go and say that's 8 centimetres. There's no need though. Okay, going through this question, I felt this was a really, really tricky question. In terms of when you're given a line here, then you want to be finding out what is its equation of a line. So you see it in the form y equals mx plus c. This m stands for the gradient, and gradient is all about how steep that line is. So looking at this line here, it's not particularly steep. The one thing I've noticed is that it's running from left to right, going this way here. So the first thing I can tell you straight away, just by looking at that graph, is that the gradient must be negative. Okay. To work out the formula, there's a couple of formulas. One's that science use. You might have heard this: rise over run. If you want to use that, it's fine. I think Miss, you've used change in y over change in x. So you need to start looking at these sort of things. So the first thing Miss has said here is graph is downhill, therefore negative gradient, same sort of thing that I was saying. It cuts the y-axis at 1.5, so you can see here 1.5. So I already know what c is. I can go and actually write that in if I wanted to, say plus 1.5, because that's where it cuts the y-axis. To work out the gradient then, you draw a triangle. Now the best thing that you can do with your triangle, it doesn't matter how big or how small it is, but just do an obvious one. You want to pick a point where it cuts, the line cuts nicely. So you see here, that's a nice point, that's a nice point. I wouldn't cut by here, okay, in the middle of nowhere. Do it on a bold line. Find another bold line here. You could have gone here, you could have gone to that one there, but again, that's not a nice point for me because it goes above 2, what's that, like 2.2 or something? And what about that one there? Again, I wouldn't use that point either because that looks like quite a nasty point zooming in on the graph there. I've got no idea how long that really is, so this definitely makes the most sense to use this point here. So you should have read that as being 4 units going across, and then Miss has done it as minus 1.5 because of it being a negative gradient. Okay. So then to work out the gradient, either using rise, how much it's risen over how much it's run, or doing your change in y over change in x, you get minus 1.5 divided by 4. Issue, in fractions, you never mix decimals and fractions together, so you need to double that top answer. But whatever you do to the top, you must do to the bottom in terms of fractions, so you get minus 3 over 8. What have you done next, Miss, looking at this? Have you started to try and work out which one of these ones here it could be? So you can start counteracting. You can say, right, it can't be a load of these here. It can't be this one here because there's no plus c. It can't be. No, it's not too many others actually that it can't be.
Can't be the next one because it's positive x.
Yeah, positive x. Anything with a positive x, we already know it's negative gradient. So that's only leaving us now with this option here, here, or here. Now we've just worked out that it's minus 3 over 8, so minus a half is not minus 3 over 8, so I could cross that one out as well. And we also know it's not minus 4. So we're starting to look at this one here being what we had, but that's still maybe a little bit worrying looking at it because it's not in the form y equals mx plus c. It's in the form 8y. So what Miss has done now is she said, let's use this one here, but we need to get y on its own. So the 8 has come over, and it must divide both of these terms here. So you get minus 3x divided by 8, which is minus 3 over 8. That's good news because we've just worked that out here. And you'd also have to do the 12 divided by 8. 12 divided by 8 is the same as 6 divided by 4. It's the same as 3 divided by 2, which is 1.5, positive 1.5. Happy days, that's what we had. Okay, so our answer was this one here. Okay, so going through what Miss said there, midpoint 2 minus 4 and minus 2, 6. You can use a formula where you add the x coordinates together, divide them by 2, add the y coordinates together, divide them by 2. So Miss has highlighted the x coordinates, so 2 add minus 2 giving 0. If you add a negative, you get 0. And then minus 4 add 6, giving positive 2. But midpoint means the middle of that, so you divide that by 2. So 0 divided by 2 is 0, and then 2 divided by 2 equals 1. So you get the answer 0, 1. But I really like Mrs. idea of saying, look, just go and draw it on the other page. If you wanted to, there'd be nothing stopping you plotting that. So what have we got? We've got 2 minus 4. So I think I need to come over here. So 2 minus 4, this point here. And then the other one being minus 2, 6, all the way up here. Draw that line and try and work out where the midpoint is. I mean, admittedly, I've not done the best line there, but if you draw a straight line, think, right, what is the middle of that line? Does it make sense of what I've drawn? My answer is no, it doesn't, because I know where it goes through. This one here then, when it asks you to write down the first 3 terms of a sequence, then the first term you sub in, wherever you see n, you change that to a number 1. Second term, sub in 2. Third term, sub in 3. Millionth term, sub in a million. 20th term, sub in 20. And they do ask things like that now and again. Okay? So wherever you see n, change it for open brackets, put the numbers in. So 1 squared is still 1. Then 3 times 1 being 3. And then adding 2 times 1 gives you the 5 there. 2 squared from this bit here is going to give you 4, so that's why that's changed to 4 there. 3 times 4 being 12, and then 2 times 2 being the 4 here, so 12 add the 4 gives you 16. Well, you can go through it again. The 2 squared gives you that 4 there, that's how that changed. Okay. Then you're going to do 3 times by that 4 to give you this 12 here. 2 times by 2 gives you the 4 there. 12 add 4 is 16. And then the final one, 3 squared, that gives you the 9, that's where that's come from. 2 times 3 gives you 6, that's where the 6 has come from. But now you have to do 3 times 9, so that gives you 27. And then 27 add 6 gives you 33. So your sequence would have been 5, 16, 33. To find the 10th term, there we go, that's exactly the point I was making a second ago. You're going to sub in 10 into this new one here. Okay, so you're going to do 5 in brackets 10 because it's the 10th term, take away 10 squared. 5 times 10 is 50. 100 squared, sorry, I've given the answer there. 10 squared is 100. 50 take away 100 is minus 50. And then finally, to find the nth term of a sequence here, this one's quite a tricky one. If you start looking at what's called the first difference, if you see here, it goes up 3, then it goes up 5, then 7, then 9, then 11. If they're all different, it's not what we call a linear pattern. So it's not going to be like 7n add 5 or 7n take away 2. Okay? You need to look at the second difference. If the second difference is constant, they don't all have to be 2s. They are in this case. They don't have to be, though. If they are all constant, it tells you that this is an n squared pattern. Okay? To work out what the coefficient, the number in front of n squared should be, you do this constant difference, so 2, divided by 2. That 2 will always be divided by 2, but this number here, the top one, that could change. That 2 is purely because all of these numbers are 2. So 2 divided by 2 is 1. 1n squared you could just write as n squared. And then why is it minus 10? Well, because it's n squared here, you need to write out what n squared term is, or what the n squared pattern is. And the n squared pattern is the square numbers. So 1 times 1, 2 times 2, 3 times 3, etc. Now, if you look here, you want to think, right, what do I do to get from n squared to get to my number in the pattern? I would come and focus just on the positive numbers at first, because you may not spot it going from positive to negative. So if we look at 36, what do you do to 36 to get to 26? Take away 10. What do you do to 25 to get to 15? Take away 10. What about 16 to 6? Take away 10. It's repeating itself. Check the negatives. 9 take away 10 is minus 1. 4 take away 10 is minus 6. So that's why that one there is minus 10. So that would need to be added in. N squared.
N squared,
Yeah? Here then. The way that they've written this out is probably the way that most of your maths teachers will try and get you to write doing things like this as a way to do it really, really quickly. It says how much did Harriet initially save in her, initially invest in her savings account. Then it will always be the number here, along like that. But like, it doesn't normally come up like this. It normally comes up that you're trying to find out how much money she has in like 5 years, and you try and arrange this formula yourself. So the answer for that bit there is £220. For the next bit here, this 1.03 is telling you that it's 3%. In terms of what 1% is as a decimal, we know that's 0.03, but 0.01. So 3% would be 0.03. And what they've done then, because you see there where it says 1.03, that's like a really, really quick way of putting 3% on something. So you're doing 100%, add 3% is 103%, is 1.03. So you can multiply it and add it on very, very quickly. So if 1% is £2.20, then 3% is £6.60. And I'll try again, okay? And then going back to how much she would have in her bank account, it would be the 220, add the 660 to get 226.60. Do this. If I'm thinking of a pair of numbers, and all I'm going to tell you is what they add together to and they times together to, could anyone tell me what that pair of numbers is if they added together to make 10 and they times together to give 16? Can anyone tell me what that pair of numbers might be? Someone said then? 8 and 2, okay? What about for the next one then? Add together to give 9, times together to give 20. What's the pair of numbers?
5 and 4.
Excellent, well done. 4 and 5, 5 and 4. And finally here, this is the hard one now, they add together to give minus 2 and they times together to give minus 24.
Oh, you just hit the minuses off and then put them on in the end.
You don't do it like that. Nice idea, it's nice to try and pick up tricks, but that doesn't work in this case. Nice one for having a go. Now, if they times together to give a minus here, then I know that one of my answers must be positive, because in this case they're positive 4, positive 5, positive 8, positive 2. But in this case here, if it times this together to be a minus, then one must be positive and one must be negative. That's the one thing I can do. Then I'd be looking at this number here, 24. What numbers times together to give 24?
12 and minus 2.
12 and minus 2. Well, let's try it. What's 12 take away 2? That's 10, isn't it? So it doesn't give me minus 2, so it's not that. But nice start, Dan. That's exactly how you start doing it. In fact, not a bad idea to write them down and show that they don't work, because now you know they don't work. Anyone else? 6 and 4 plus 6 minus 4. Does that work?
No.
But it's close, isn't it? Because what is 6 take away 4?
2.
That's positive 2. I've got negative 2. So literally all I need to do here is change it. Instead of being plus 6, it should be plus 4 and minus 6. Yes, spot on, Dan. Okay? If you think like that for this next bit, it will help you work these out, okay? That thing that I was just doing up here, that is what's going on here. I'm saying a pair of numbers that add to make minus 4 and multiply to get negative 21. Okay? So what pairs of numbers times together to give 21? Minus 7 and? Excellent. Okay? So, scrolling down here, what Miss has done now is she's split up that minus 4x here into those numbers that we just said, minus 7 and plus 3. So we've got x squared minus 7x plus 3x minus 21. Then, if you were to put that together again, you would get this thing here. So that is identical to that. And then what she's done is she's factorised this first bit here. So if I put like brackets around there and there, and there and there, and she's pulled out what we call common factors. And it doesn't matter if you've done the -7 first or the +3 first. The one thing I would say is your second number, try and get a plus sign there if you can. It'll make things easier. She's pulled out the x outside the bracket because it's common in both, divided the inside of the x just like we did before to get x, and then x minus 7. She's done the same thing here. She's pulled out 3, and then she's got x and minus 7. Because that bracket there is x minus 7 twice, you know you've definitely done the right thing. Okay, that's telling you you've done the right thing here. So then x minus 7 is one of my brackets, and the other bracket is what is outside. So the x and the +3, so x plus 3 goes in the other brackets. Okay. From there, it says, hence solve equals 0. If I was to say, like this diamond here, multiplied by this question mark, is equal to 0, how do I make two numbers times together equal 0? 5 times what equals 0? 0. One of the things has to be 0. So either this diamond thing here, that was 0, or this question mark here, that was equal to 0. Okay? So what Miss has done here is she said that this bracket here is either equal to 0, or this bracket here is equal to 0. So that minus 7 going over to the other side would become plus 7, or just 7, and this 3 here goes over to the other side and becomes minus 3. So whatever you've got inside your bracket, this will always be the opposite sign for your solution. Okay? I'm just going to double check. We're more than happy with just adding together fractions like from back in the day. So 3/7 plus 2/7 would give us 5/7. Like common misconception from back in the day is that it's 5/14. But when the number on the bottom is the same, it literally just stays the same there. And if you really want to think about it in an obvious way, think of it as slices of cake. 3/7 of a cake plus 2/7 of the cake would give me 5/7 of the cake. Yes? What about if I had 1/2 though plus 1/3? Well, truth be told, I can't actually do it because these denominators are different. So what we do is we use equivalent fractions so that we can answer them. Okay? So, what's the number that goes into both, or that 2 and 3 both go into? The smallest one I can think of is when I times them together and get 6. And I've just sort of given a bit of a hint of what I did there. What did I do to 2 to make it 6? I times it by 3, so this must be times by 3 as well on the top. So 1 times 3 gives me 3/6.
So I didn't even know at 11.
Well, I'd say they're probably about to go back into the room. Okay. What have I done to 3 to make it 6? Well, I've doubled it, so I must double the top here. Now that they have the same denominators, I get the answer 5/6. So that answer would also be 5/6. And if you put that into your calculator, that's exactly what it will tell you. Okay. Using that to help me with this, the issue that we have here is that each fraction has, not each fraction, but these two here are certainly different. Because they're different, I need to make them the same. So I need to pick a number that 3 and 2 both go into, so I can use 6 again. So what do I do to 3 to make it 6? I double it, but as long as I double the top, I get an equivalent fraction, and it's absolutely fine. I don't need to cancel down, I don't need to divide by 2 at the end, so I just need to double both top and bottom to keep it equivalent. Then I'm going to triple the top and the bottom for this one here, and then to make it equivalent here, I've got to times this by 3 also. Okay? So the next line that you should have, so if you didn't have this, if you want to write it down now, is 2, and then a bracket here, because it's both parts of those that are doubled, 6, and then you can see here they're all 6s on the bottom, 3, and then the bracket here, and then 3, and the bracket here with the 6. Now if I just shift back to what I did a second ago, when I had 7, 7, 7 on the bottom, all I need to do was just do 3 add 2 to get the 5. And that's the idea I want to use here. If I've got these all over 6, you can forget about the 6s, they all cancel out. I'm looking at just literally adding together these two parts here to get whatever this answer here is. So what you do next is eliminate those 6s, pretend they don't exist anymore, and you expand your bracket, so 2 times 2x give me 4x, 2 times 3 give me 6, 3 times 4x give me 12x, 3 times 1 give me 3, and then 3 times 43 give me 129. And then collecting my like terms, I'm going to get 16x plus 9 equals 129, taking away 9 from both sides, or if your maths teacher taught you to take over to the other side, you'd change into minus 9. You get 16x equals 120. And then Miss has done this a really clever way of sort of like cancelling down, although you can see here, for saying x is equal to 120 over 16, that gets you full marks. It's absolutely fine to be doing that. If you wanted to, you could half top and bottom, half top and bottom, half top and bottom, until you eventually get 7.5. But it is a non-calculated paper. You wouldn't have to do that. It's absolutely fine to write that because it's what we call an equivalent fraction. Okay?
Year 11, I totally get. It's a really...
Okay, so couple of ways to do this. First things first, E the subject of the formula, or making E the subject of the formula, means it must be, your very final answer must be E equals blah, blah, blah. Okay? If worst came to worst, you've gone completely blank, you couldn't remember what on earth to do when it looks like this, just write down what I just said. You may get a mark for it. Not definitely, but on a good day, if you get an exam in a good mood, you might say, well, that's true. Yeah, you can have a mark for that, okay? Two ways to do it. You could either expand this bracket out first. That's personally what I would do. But Miss has actually done it the other way around, where she said, look, I don't want this denominator here, so I'm going to lump that together and take this round to the other side. Okay? So the first bit that Miss has got is still keeping that as a bracket, D, and then your 2 plus E from that bit there is equal to 3 times by this bracket, because it was divide by when it's on this side. Okay? Absolutely fine to have expanded that bracket first, doesn't matter at all, because now Miss has expanded the bracket. She's got 2D plus DE is equal to 15 minus 3E. Now, because it's making E the subject of the formula, we want to get everything with E all on one side. Things I don't like is when E is negative. This one's positive, that's fine. Let's get rid of this one here. So what Miss has done is she's added 3E to both sides. Alternatively, what you could have done instead, anything with E, take on to the left-hand side. Now she's got 2D plus DE plus 3E. Now you're making E the subject of the formula, so anything that hasn't got E on this side, get rid of it. You want all the E's on one side, anything else on the other side. So now it's time for that 2D to go. So taking 2D off both sides, here and here. That means 2D take away 2D would be gone, but this side is going to give me 15 minus 2D. Next, I've got DE plus 3E is equal to 15 minus 2D, which you can't answer because you've got numbers and letters. Then, because it's E that we're making the subject of the formula, Miss has factorised by E. She's taken E out of both of these things here, so then brackets here and here, and then dividing this by E gives me just D. Dividing this by E gives me 3, so D plus 3. If you expanded that out, it should give me what I have up here. And then, because this E is multiplying this bracket here, it means E times that by that bracket. If we divide by that bracket on both sides, we finally get 15 minus 2D over D plus 3. And you can keep that in a bracket if you want to. Don't have to, but some people like to keep it in a bracket. When I was your age, that's what I used to like doing. Okay, but I'll let you have a look at this full solution there. This is a question on something called upper and lower bounds, okay? They put it in bold here. It says the nearest kilogram. Now, if it ever says the nearest anything, it means the nearest 1 kilogram. Whenever you're working with upper and lower bounds, what you want to do is halve that number there. So 1 kilogram divided by 2 would give me 0.5 kilograms. To find its upper bound, you would always add it on. So we've got 3 kilograms here in the question. So to find its upper bound, 3 kilograms plus 0.5 kilograms gives me 3.5 kilograms. And to find its lower bound, you would do the 3 kilograms, take away 0.5 kilograms. So you get 2.5 kilograms, okay? Now that means that if you were to round those numbers to the nearest kilogram, if I was to round 2.5, it would go to 3. And this is the bit where people get really confused on. They say, well, 3.5 rounded to the nearest kilogram, gives me 4, doesn't it? Your lower bound is what the lowest it possibly can be. So if it was 2.4, it would be going down to 2. Your 3.5, your upper bound, would say, look, it can actually never quite reach this answer. If I was to be really, really, really fussy, this would be 3.4. And then you could say, well, what isn't it 3.49? And then someone would say, well, you could keep on doing the 9 and put a dot on its head to mean recurring. If you put in 3.49 reoccurring into your calculator will tell you that answer is 3.5. Okay, so the quick way of doing it, nearest, halve it, add that on, take it off to find your lower and upper bound. So then to find this bit here, it says 5 potatoes. Now they could have weighed an absolute, their lowest bound of 2.5 kilograms. Because it's 5 bags, multiply it by 5. 2.5 times by 5 if you need to, count them 2.5 times table, write it out if you need to, 2.5, 5, 7.5, 10 and so on, and you get 12.5. Okay? Right, you're told here that the formula that they're going to be using is y is equal to 4x cubed minus 12x squared, and they've found a load of the values for you already, but they've asked you to find it for -1 and +1. So wherever you see the x, same methods that we've been doing throughout the paper today, wherever you see the x, change it for open brackets, sticking in what the value of x is, so -1, -1. Now -1 cubed means -1 times by -1 times by -1. Now we know this bit here, -1 times -1 would give me just 1. But then you'll times that again by -1, so 1 times -1 will give -1. Okay? Then you're going to be doing -1, you're going to times that by 4. So that's going to give you the -4 bit there. And then you're doing -12 times by -1 squared. -1 squared is just this bit in the circle here. We've already said that goes to being +1. So then you're going to get -12 times by +1. And a minus times by a positive gives a minus. So yeah, that's why we're saying it's hard. We recognise that's hard. It is tough at. So then you're going to get -4 minus 12. And if it was -4 degrees and then you drop down a further 12 degrees, you'd be on -16. Okay? So that's why that's -16 here. For when it's 1 cubed, we don't have to worry quite so much about all the negatives and stuff and minus times by a minus, blah, blah, blah. 1 cubed just means 1 times by itself 3 times, so 1 times 1 times 1. So that would just be 1. 4 times 1 is 4. And this is 12 times by 1. 12 times by 1 is 12. But remember, it was a minus here. So that's why it's 4 times -12 here. Okay? 4 take away 12 is -8. So that's how we got the -8 there. Okay, now on this graph here, you're going to see some things that we're not actually going to go through today. In terms of plotting all the points here, that's just along the corridor, down the stairs, up and down the stairs, just like we did before. And it does, this blue line here, this is the one that you want to be able to plot. Okay, anything with a squared, anything with a cubed is never going to be a straight line graph. It is going to be a curved graph. You should plot all your points first and then try and freehand curve it like that. Okay?
Can I just